not match, so we have to use this one. And it says angle P. Angle P is this one. So the easiest thing to do, if you're getting messed up with these, is to highlight the entire angle. All right, we highlight the entire angle. That's angle P. And then we highlight the entire angle PSR. Maybe I'll use green for that, or purple. Let's use purple. So PSR would be that angle there. So this angle versus this whole angle, it must be same side interior. They're on the same side of the transversal, and they're on the interior. Yes?
So if this were like on a test, like and like you were confused, like could you tell the answer by because they both have P in it?
Nope. No, you couldn't.
Oh, so you'd have to like really look at the.
You have to really look at it. Yeah. Don't judge it by the letters. Okay? And then the next question was angle 2 and 3. Who's got that? 2 and 3? Robin.
Alternate interior.
Alternate interior angles. Awesome. And then number 3 was angle 5 and PSR. Who's got that one? Evan?
Corresponding.
Corresponding. Let's double check. So I said angle 5. Let me erase this crap. I said angle 5. Let's color it in purple. I already forgot the other angle. I was trying to do PSR. So I'm looking at this angle and this angle. That is definitely corresponding. Awesome job. Cuckoo, kachoo. All right, questions on the homework. We're going to have to really condense time because we've been taking way too much time going over questions on the homework. Remember, if I don't get to your question, come see me, okay? It doesn't mean I'm just blowing you off. Evan.
25.
25.
Proof. I just didn't know how to set it up.
Oh, okay.
Like after the given.
So you got the given down?
Yeah.
Nice. It's not really a proof. 25, although it looks like a proof, I am not asking for a proof.
Were you just asking for angle 1?
I'm just asking for a measure of angle 1.
Really?
And you, right?
Yeah, I did I was like scared to like if I did do a proof it like.
And what would kind of tip you off is they gave me stuff, but does it say prove the measure of angle 1? It just says find the measure of angle 1. And let's quickly talk about the measure of angle 1. Glad everyone's phone is off and in their lockers. Yeah. Sure. 60 degrees. Yeah. How'd you get 60 degrees?
Well, so that angle before would be 5, and then angle 2 is equal to angle 4 because corresponding angles.
Well, 1 is equal to 4 because of corresponding. Yep. But 2 is...
2 is alternate interior 5, and 6 is alternate interior 3.
They're all equal. And if you didn't catch what just happened there, we proved up here. Remember 24 yesterday? We proved that angle 1 and angle 2 were the same. Because we said 2 was equal to 5. And we said 4 was equal to 1. But 4 was equal to 5. So 2 and 1 were the exact same angles. Those two were the exact same angles. All right? And then we're also going to know that angle 3 is the exact same angle because it says SB bisects AST. So this line bisects 2 and 3. So all 3 of these angles are the same. And what do all 3 of these angles add up to? 180. 180 divided by 3 is 60. This is 60, this is 60, this is 60. No proof required, but thanks for bringing that up. I knew that was going to come up. So be very careful about if it doesn't say prove. If it said prove it equaled 60, then you'd have to have a proof. But I was just asking you to find it. Sabrina.
So I understood 7 through.
Okay, what's your question?
I just didn't really understand 14 through 16 and number 17, number 18, number 19. But I'll ask about number 14 first.
Okay, because we can't get to all those. We just don't have time. So I'll just do 14, and then I think I'll talk about one of those later ones because I think people will have questions on that. And then we do have to start the lesson. But if you have more questions, please come see me. I do see people before and after school, which is awesome. Okay, number 14 says find the values of x, y, and z. So what I'm going to do is I'm going to look at the numbers that are given to me. All right? I'm going to look at 24. And my immediate thing is look at the alternate interior. Well, that doesn't help me get a letter. So I'm going to look at the other number. This one says 56. So I'm going to look at the alternate interior. And alternate interior angles have to equal. So we're going to have x equaling 56 degrees. Then what I'm going to look at y and this whole angle here. All right, I'm going to look at y and this whole angle here. Well, y and that whole angle are same side interior. And in fact, these two angles are same side interior as well. And remember that same side interior has to add up to 180 degrees, or supplementary. All right? Yes?
Is y 100?
I don't know. Maybe. Yes, it is.
56 plus 24 is 80.
Yes, it is. Yep. So Evan noticed that, well, this whole angle equals 100 degrees. Right? So he said that this whole angle is 100 degrees.
No, it's 80.
Or 80 degrees. Yeah, you got the y. Yes, you are correct. So he realized that this was 80 degrees. And he said that since these are supplementary, they have to add up to 180 degrees. So that makes this 100 degrees. It also means that 4z equals 100 degrees. So what does z have to equal if 4z equals 100? It's going to equal 25. Does that make sense, Sabrina? So you just have to worry about corresponding alternate interior and same side interior. Know what they mean. Yes?
But how did you know how, like, what the angle is equal?
Because this one was 56. This was our key to all of them.
Oh, yeah, because
Because as soon as I'm just trying to find one value that I know. All right? And then you're going to know by looking at these two things. So you have two numbers here. You're going to look immediately for alternate interior because then you know they're equal. Okay? And then if you can't find a number like that, you got to look for corresponding. You have to look for same side. All right? So find your first variable and then work your way around from there. Don't look at all of them and say, I can't solve them all at once, because you can't. You got to find your first number and then go there. All right, then the other question I do want to go over, and then we will be moving on. We just don't have time in the day. 18 and 19. I think we're probably going to have questions on those. And hint, hint, this problem will come up again. All right? This is an important problem to know how to do. Okay, they give us too much information all at once. Because you might look at that and be like, it's too much stuff going on there. So what I'm going to do is I'm going to get rid of some of the information for just a second. I'm going to look at just this angle and this angle, noting that this is parallel to that. This and this have to add to what? They have to add to 180. So just because they're the same side interior, correct? So based upon that top thing, we know that 120 plus 2x plus y has to equal 180 degrees. I can't solve for variable, right? Because I have two variables there. So I'm going to bring in the next one. Well, that's the same information. It is 2x minus y plus 140 equals 180. Now I have a system of equations. Either I need to use that substitution kind of thing, or we can use elimination, which is our adding. Okay, it was what we practiced, was it this week or last week? Whatever, we practiced those solving. So you might have to look back at how to solve equations, but that's all this is solving two linear equations. Okay, yeah?
And how would you put the answers together?
How would I put the answers together? What do you mean put them
Or
together?
as in, like, put that whole problem, is it like the thing where you do,
So I guess I would really quickly start it off. So I'd rearrange this as 2x plus y plus 120 equals 180. And then right below it, I'll put the other equation, which is 2x minus y plus 140 equals 180. And then I would go ahead and add both of these things together. So that would be 4x. My y would eliminate. I'd have plus 260 equals 360. And you'd solve from there. And so you might have to look back at how to solve linear or how to solve systems of equations, okay? I just don't have time to teach that again. All right, we have to get into today's lesson. We have to. It's already taken a bit too long. All right, we already did postulate 10. I'm just going to put postulate 10 and postulate 11 together. So postulate 10 said if two parallel lines are cut by a transversal, then corresponding angles are congruent. So if we saw something like that, and we said L is parallel to N, which would look like the little arrow things. If L is parallel to N, then angle 1 would be congruent to, how about I put angle 1? Would be congruent to angle 2. Alright, so we use postulate 10 to prove corresponding angles are congruent. That is the whole point of postulate 10, is to prove corresponding angles are congruent. And I want to put that next to postulate 11 because postulate 11 looks almost the same. And you have your postulate sheets and stuff, right? Okay, awesome. Number 11 has kind of a tweak to it. Number 11 says if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So 10 starts with if they're parallel. Number 11 starts with if they are congruent, then they're parallel. So this one goes the opposite direction. It basically says if angle 1 is congruent to angle 2, then L is parallel to N. So we use, why'd you quit me? So we use postulate 11 to prove two lines are parallel. All right, we use this to prove two lines are parallel. Now that's big, because we can now go both directions. I can either say two things are parallel, and we can say corresponding angles are congruent, or I can just tell you these things are congruent, and you could say, hey, then I know they're parallel. So we can go both direction with it using either postulate 10 or postulate 11. Just make sure you keep that straight. All right, if I'm trying to prove something's parallel, I'm going to use postulate 11. If I want to prove two things are congruent, then I'm going to use postulate 10. Subtle difference, but it's huge when you're doing your proofs, correct? Does that make sense? Why they're, bless you. And that's why I put them right next to each other so we can see the big difference between the two. All right, let's go right into a proof. Because that's our favorite part of proof writing, right? So it says, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Once again, theorem 3.5 is another way to prove that two lines are parallel. So today we're focusing on how can I prove things are parallel. Where yesterday we said if they're parallel, what can we say is congruent? So we're just going the opposite direction. So we are given that angle 1 is congruent to angle 2, and I want to prove that L is parallel to N. I know the first step. I'm going to get it. I'm going to get it this time, Evan. All right, angle 1 is congruent to angle 2, and that is my given. We only have one way to prove that two lines are parallel right now, because it was the one thing that I started with, and that is postulate 11. Postulate 11 says if two corresponding angles are congruent, then my two lines are parallel. So I want to prove that two corresponding angles are congruent. What should my next step be? Grace, I saw your hand first.
You could do angle 2 and angle 3 are congruent because they're vertical angles.
Yeah. Angle 2 is congruent to angle 3, and that's definition of vertical angles, or you could just put vertical angles. Okay, I have 1 equal to 2. I have 2 equal to 3. My goal is to say 1 equals 3. Can I say that right now? Amber, why can I say that right now?
You can use substitution.
Is there a better one? Not corresponding angles. Is there a better thing besides substitution? If I have a train, transitive would probably be a better one. Is that what you had? Yeah. Angle 1 is going to be congruent to angle 3, and that is going to be transitive. Could I have used substitution? Yeah. You could have used substitution because realistically I could say I'm replacing 1 with 2. That technically is substitution. But transitive is a much stronger, better way to say it. Because if you say substitution, you have to defend yourself.
Would you take off? We said corresponding angles theorem.
The corresponding angles theorem.
For angle 1 and angle
Like if you know that corresponding, then they have to be congruent.
Oh, yes, I would take off points for that. Because the only time we can use corresponding angles is if I know they're parallel first. We are trying to prove they're parallel, correct? So we can say corresponding angles are congruent if they're parallel. Only if they're parallel. Alright, we're going the other way. We're saying I don't know they're parallel. So I'm going to go along and say that I'm proving that they're congruent. And that way I'm showing that my corresponding angles are congruent. Then I can say they're parallel. Okay, it works backwards, right? Alright, so my last step would then basically be my corresponding angles one, that postulate 11. That would say, so we use transitive. So my next step is L is parallel to N, and that is going to be postulate 11. And postulate 11 says, if my corresponding angles are congruent, then they're parallel. So by using corresponding angle theorem, you're assuming they're parallel to start off with, and we can't assume they're parallel. Does that make sense why you can't use that? It's going to be a common mistake people are going to make. Alright, so I'm glad you brought it up. Do not use the things that we used yesterday. We're just trying to prove it's parallel. Yes? Yes? Yes?
Wait, postulate 11?
Yeah, postulate 11. Because postulate 11 proves that two things. Alright, so we have two ways to prove things are parallel right now. We have if my corresponding angles are congruent, we have parallel lines. And now we have if alternate and interior angles are congruent, we also have parallel lines. Those are our two ways to prove right now. So that's postulate 11 and theorem 3.
We're like screaming over there.
I guess he really had to go to the bathroom. Alright. So my theorem 3.6 says if two lines are cut by a transversal and same side. Ooh, weird. Now we're going to go from same side. What do we know about same side interior angles if they're parallel? Not congruent, they are. They're supplementary. So this one's saying if I prove they're supplementary, then they are parallel. So I'm going to do the first one because I'm awesome at that. Angle 1 plus angle 2 equals 180 degrees. And that was the old given. The old given. So my goal right now is to either come up with either corresponding angles being congruent or alternate interior angles being congruent. All right. Which one do you think we're going to use based upon the numbers that I gave you? Yeah.
Alternate interior.
We're going to be looking for alternate interior angles. So I want to find a way to say 1 and 3 have the exact same measure. All right. That's going to be my end goal. So we're starting with angle 1 plus angle 2 equals 180. Remember, if you don't know where to go, state things you know. Whew, that rhymed. Did everyone get that? Everyone should write that down right now on a big poster board. Things you know, you should show. All right. What do we know about 2 and 3? Yeah,
They're supplementary.
they're supplementary, so they equal 180. I'm trying to remember if I actually wrote their supplementary or I just went right to the 180. I went right to the 180. So we can say measure of angle 2 plus measure of angle 3 equals 180 degrees. And I'm not going to use the definition of supplementary because I'm adding two angles together. So the better one is,
Angle and
yep,
addition.
I gotcha. Angle, addition, postulate. All right, so I have 2 plus 3 equals 180. I got 1 plus 2 equals 180. Somehow I need to get to 1 equaling 3. What do you got, an idea?
Angle 1 plus angle 2 equals angle 2 plus angle
Oh, that is so awesome. That is so nice. Because if I do measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. How do I do that? I must use some kind of property. Substitution. Awesome. I use substitution. Now I need to get rid of 2 and 2. And remember, to make a nice, elegant proof, we first have to say they're equal to each other. I got to do my reflexive. Yeah, just to make it nice and elegant, we have to do the measure of angle 2. I don't even know if I put space for this. Equals measure of angle 2. That's our reflexive property. Is like looking in a reflection. So we're actually going to have to add an extra step in here because I want to make it look really nice and pretty. So there actually is a 6th step. My next step is going to be measure of angle 1 equaling measure of angle 3. Jacob, how did I do that step? Subtraction. Yeah, our subtraction po. Our subtraction po it up. And then my very last step is I do have to add an extra one because I did want to make it look nice and pretty. And that is L is parallel to N. And that is because I just proved that alternate interior angles were congruent. And that would be theorem 3.5, or you can say the alternate interior angle congruent. I'm going to put 3.5 because it's just a little quicker to write. But did I put the wrong one?
3.5 or 3.6? Oh, wait.
3.5.
Oh, you flipped pages. Okay.
Because alternate interior angles. Yeah, sorry.
Wait, so it'd be
It says 3.6.
angle 3, 5, or what?
Or you could just say alternate interior angles are congruent. I would understand what theorem you're using then.
Same side?
No. I'm using
Oh, theorem 3, 5.
I'm using 3.5 to say, hey, if these two things are congruent, then they're parallel, because that's exactly what 3.5 says. It says if alternate interior angles are congruent, then they're parallel. That's what 3.5 says. So remember, we're going the opposite direction. All right, we got one more to go through. If a plane, in a plane, if two lines are perpendicular to the same line, then those lines are parallel. This is going backwards as well. Remember yesterday we did if they were parallel and one of them was 90 degrees, then both of them are 90 degrees. That's what we did yesterday. Today we're saying, well, if they're both 90 degrees, then they're parallel. So let's start with the given. We have T is perpendicular to L. We also have T is perpendicular to N. That's my given. Now anytime they give me something like that, I want to unpack it, right? I want to say, why is that important to the proof? Why is being perpendicular important to angle 1 and angle 2? Amber.
It means like equal to 90 degrees.
They're both equal to 90 degrees. That's just unpacking it. So I can just say measure of angle 1 is equal to 90 degrees. And measure of angle 2 is equal to 90 degrees. And that's just their definition of perpendicular lines. Now let me just do the drawing. It saves me time. Well, if I prove this is equal to that, didn't I prove they're parallel? Because don't we have something saying that if I show that corresponding angles are congruent, the lines are parallel? Yeah.
Or postulate 11.
Postulate 11. Can I show that 1 and 2 are equal? That's I'm just jumping right. Can I show that? Can I write in the next step that they're equal?
Yes.
Yeah. I can go ahead and say that, angle 1, maybe I should use measure. I can say measure of angle 1 equals measure of angle 2. And I'm going to go ahead and use substitution for this one. And thanks to Grace and her ability to flip back, we know that's going to be postulate 11 that tells me that's true.
Did you also do like...
Nope. Oh, maybe.
Oh, I thought you could... I did postulate
You told me it was botched at 11. Why would you change it?
No, I thought that was for the third.
Oh, okay. No, the third one's just substitution. If this equals 90, this equals 90, I can just go bloop, plug that in for that.
You always use the prompts, we ended up here in the last step.
Yeah. Yeah. Any questions on any one of those? No? Okay, so we have a bunch more proofs here. We have a bunch more proofs here, and what I want you to do right now is work in your pods on those proofs. We're going to switch it up again. We're going to switch it up. Same people that moved last time are going to move again. You're just going to move to the other pod. You hate moving that much?
Yes.
They'll move next time, don't worry about it. You guys move twice, they'll move twice. Alright? In fact, I think on Friday we're going to have a new CD chart as well.
You guys just gonna miss that.
That's okay. Alright, let's go ahead and move. So you two are going to be up here. You two are going to move here. No, I went the wrong way.
They were over here.
Yeah. You two are going to go here. You two are going to go here. And Sabrina, you're going to go to that pod there. No, you guys are going to go here. We got it straight.
Oh, we're doing opposite what we did last time.
Yep, opposite of what we did.
Okay. Come on, Abby. I can grab it.
Alright, so if you worked ahead, that's okay.
Yeah.
Go back to the first one and work with your whole team on it, okay? Work with your whole pod on the very first one. Make sure you have the steps correct. Make sure everyone agrees with it. Do not move on until you think everyone's got it, alright? While they're writing, you can kind of move on, but make sure you catch them up to speed and they understand.
I think the first step is a definition of physical properties.
Lego property. Angle addition postulate.
Oh yeah, we got that.
Yeah.
Alright, the first one is not that one. It is this guy here. So I'm going to write down my givens. They're pretty much the same given, so you could have put it in 2 steps. I'm just going to put it in 1 step. I'll put angle 1 is congruent to angle 2, and angle 4 is congruent to angle 5. The reason is, hey, guess what? They gave it to me.
It's given.
It's given. Everyone's got that one right. Yay! We all got a point. All right. Think of all the different ways you can prove 2 lines are parallel. We can use corresponding angles. I probably don't want to use corresponding angles because that means I need to create like one out here that matches up with this one. So I'm probably not going to worry about that. I'm looking at maybe alternate interior. We have alternate interior that proves it. We have same side if the same sides are supplementary. So I'm looking at basically those 2, alternate interior or same side. So my goal is either to prove that 1 is equal to 4 or 3 is equal to 6. If I prove that, they are parallel. They are absolutely parallel. So I have 1 is congruent to 2. I have 4 is congruent to 5. Didn't I say one of my goals was to prove 1 is congruent to 4? Well, 1 is congruent to 2. 4 is congruent to 5. What about 2 and... What do we know about these 2? Yeah. They're vertical angles, so they must be congruent. So my next step is do our vertical angles. Angle 2 is congruent to angle 5. And that is our vertical angles. Well, if 1 is equal to 2, 2 is equal to 5, and 5 is equal to 4, what do I know about 1 and 4? What was that? They're congruent as well. So my third step would be angle 1 is congruent to angle 4. And that could either be transitive or substitution. I'm going to go ahead and use transitive. Yes?
We put down for step 3, at first we put down angle 1 is congruent to angle 5, and then we put down angle 1 is congruent to angle 4.
Yeah, that's what I have.
But at first we put down angle 1 is congruent to angle 5.
1 is congruent. How did you know 1 is congruent to 5? Did all 3 of you have that?
I was doing angle
Oh, okay. So I think the rest of your group had the 1 and 4.
Oh, I can. Oh,
I think maybe you wrote down the wrong thing.
I think we did have it, and then we kind of erased it, so I forgot to erase it. Sorry.
Okay, so we have transitive property. 1 is congruent to 4. They're alternate interiors. So my 4th step is I'm done. I can go ahead and say they're congruent, or they're parallel.
Wait, what about 3 and 6?
Why do I care about 3 and 6?
I thought we were supposed to do that. I don't know.
Nope, if you look at theorem 3.5, all it says is you just need to show one pair of alternate interior angles are congruent. You just have to show one pair of alternate interior angles are congruent, and then they're parallel. Did I show one pair of alternate interior angles are congruent? Do I need to show another pair? No. You could, but it'd be a whole bunch of extra work. All right, kind of use that for the next one. All right. Once again, we're given that angle 3 is congruent to angle 6. Angle 1 is congruent to angle 4. What did I want to do with this one? All right, so go ahead and try that one. It takes 3 steps.
First one's given.
If you do it correctly, it takes 3 steps. The given includes 1 step.
Yeah, I think I just want to like once.
Or I really do.
No, Thursdays, every Thursday.
So once again, the last 2 are homework,
Yeah, no, but every other.
Every other week is wrong.
and skip number 21.